Hello and welcome everyone to the EOPF Explorer launch webinar. I am Sabrina Zito from Thrive Geo and would like to warmly welcome you together with my colleagues from the European Space Agency, Development Seat and EOX to our Sentinel Zarr Explorer launch. Just so you know, this webinar is being recorded and will be shared online afterwards. Audio and video from participants are not being recorded, and we'll be using the Q&A tab at the end of the webinar for our Q&A session. So here's a roadmap for what we will cover today. Today's webinar has 4 key parts. First, we'll be introducing EOPF and explaining why cloud-native formats matter. Second, we'll get to know the EOPF Explorer and walk through the user journey. Third, we'll demonstrate example applications in action. And finally, we will have about 30 minutes left for your questions. So let's dive straight in. Before we explore the tool itself, it's essential to understand the context. So the Earth observation landscape is undergoing a fundamental shift to cloud-native workflows, and EOPF is at the heart of this transformation. Let's contrast the traditional workflow with the cloud-native approach. So traditionally, you download entire datasets, often 500 megabytes to several gigabytes per scene, store them locally before analysis, and you'd be limited by your storage capacity and bandwidth. With cloud-native workflows, everything changes. You can get dynamic rendering without downloads, you access only the data you need when you need it, and you work directly with data in the cloud, allowing you to scale up your analysis dramatically. So let's put this into perspective. The Copernicus Sentinel archive holds over 90 petabytes of data, making it the largest open Earth observation dataset on the planet. Sentinel-2 alone accounts for nearly 50 petabytes, while Sentinel-1 contributes over 33 petabytes of data. This entire archive is transitioning to a new cloud-native distribution format called EOPF Zarr. This announcement represents a monumental shift in how Sentinel data is produced, stored, and consumed. So why does this matter? Well, this opens up possibilities for what you can do with Sentinel data in many exciting ways. So first off, what exactly is Zarr? At its core, Zarr is a multi-dimensional array storage format designed specifically for cloud environments. It's built on an open specification with a growing ecosystem of tools. Here are 4 key technical features that make Zarr transformative. First, chunking. Data is divided into manageable pieces, which facilitates scalable, distributed data processing. You can send each of these chunks to a separate machine, which can compute the answer for you. Second, parallel access. Multiple chunks can be read at the same time, which improves performance dramatically. And third, partial retrieval. So you access only what you need and not entire files. So how many of us in the audience have cropped areas of interest out of entire scenes? Partial retrieval allows you to skip some of this. And finally, Zarr offers compression, which reduces storage needs without sacrificing access speed. This combination of features makes it ideal for the massive scales we're dealing with in Earth observation today. So what is EOPF? EOPF stands for Earth Observation Processing Framework. It is an ESA initiative for modernizing Copernicus data using cloud-native and open-source technology. This is essentially a new approach to processing and distributing Sentinel data. What makes EOPF powerful is its standardized format across missions. There's a single meta model applicable to all Sentinel-1, 2, and 3 land missions. Regardless of which satellite captured the data, the structure remains consistent. Each EOPF product contains measurements, quality information, conditions, and attributes, each organized in a predictable and accessible way. This standardization dramatically simplifies processing and working with Sentinel data across multiple missions. So we're in a time of transition to EOPF, and to support this transition, ESA has developed 3 key resources. The first is the EOPF Toolkit, which helps you to learn the basics and get started with the technical fundamentals. The EOPF Zarr sample service lets you discover the reprocessed data hands-on with a dedicated playground environment. And the EOPF Explorer, which we'll demonstrate shortly, allows you to visualize data and tell your story. These three resources work together to provide a comprehensive journey and pathway for the community to adopt EOPF Zarr. And whether you're just starting out or you're ready to build production workflows, you can try it out yourself. All these resources contain tutorials, examples, as well as tools and libraries to help you work with and visualize EOPF Sentinel Zarr data. So to summarize, EOPF Zarr is great news for us in the EO community. It represents one format that works across missions. It's cloud native by design, built for modern infrastructure. It's interoperable, working seamlessly with the broader scientific ecosystem and cloud platforms. And critically, you're working with APIs instead of files. This shift to API-based access is what enables all the benefits we've discussed. For researchers, that means faster analysis with even bigger data volumes. For commercial and public data users, it means it is easier to integrate EO data into your operational workflows. And for the geospatial developers in the room, it means you can use open source tools to build new applications and awesome data visualizations. So now let's move on to the second part of our webinar, the EOPF Explorer itself and the user journey to see what these concepts mean in practice. So please welcome my colleague Jonas Schofstein from Development Seat, who will show you what's possible today for data visualization. Thank you.
Thanks, Sabrina. Yeah, hi everyone. So I will just give a brief introduction, and then I will hand over to Emmanuel to walk you through some concrete examples. So yeah, what you can expect from the Explorer project, the EOPF Explorer project, is that we really dive into this future of what if we take the EOPF format and enhance that for visualization and really bring it up to par with what we've seen with the COG format and so on, what's possible. And we yeah, and that covers a wide range of steps in the EO workflow. And can I get the next slide, please? And for us, really, the key thing is we don't just want to like show some demos or some hypotheses, but really pave the ground and prepare you for the future of EOPF data for Sentinel, and also to bring in this element of GeoZarr. And the key here is we already did a lot of work to make the tools that you've probably already been using ready for this format. So stack extensions, TiTiler for dynamic tiling, OpenLayers for browser-based visualization on the map. GDAL is advancing as we speak, so some of these things are not just like in major releases yet, but they're very close to getting there. And this is really to give you tools and data into your hands to try out this future scenario. Next slide, please. And we structured this to make it a bit more tangible for you, because there's so many things you can do with EO data, as many of we know. And so we structured this into these three stages. And the first one being the resource discovery, where you try to find the products that cover your area of interest. And the second one, where you actually dive into the products. And this is also where this cloud optimization comes in very handy before even processing or downloading a lot of data. And these two are the ones that we'll focus on in the webinar today. And then the third stage being analysis, where you really work with the data. We also are touching upon that in our project and showing how the EOPF and GeoZarr can ease that a lot. And that will be subject of our next webinar, and we'll get back to that shortly. So over to you, Emmanuel.
Yeah, do you see my screen properly?
Yes, thank you.
Okay, thank you, Jonas. Yeah, and so let's start with discovery. This is the entry point of the platform. The EOPF Explorer exposes a standard stack catalog where you can browse the collection, see thumbnail at a glance, and get an instant preview of every scene before you even start visualizing. So let's start from the beginning. This is the landing page of EOPF Explorer. And as already mentioned before, this is organized around 3 main stages: discovery, screening, and analysis. In this first demo, we will focus on discovery and then on screening. And I opened the STAC catalog. STAC is the backbone for the data discovery, and it deserves attention in our capacity building journey. And at the moment, the catalog contains mostly Sentinel-2. Sentinel-1 and Sentinel-3 will be also available this quarter with more data. So I open the Sentinel-2 L2A collection, and immediately we get a page with items with thumbnails for every single one. All those images are generated on the fly by TiTiler directly from the raw band data. There is a caching system for avoiding to read the same data multiple times. So let me search for a specific area, the strait between Denmark, Sweden, and Norway. We will choose a low cloud cover because obviously clear sky are better for screening. And we see that the search returns multiple page and every result that says thumbnail available. Now, I will pick an item. And as you can see, the map zoom and it overlays the preview. And if I start navigating, you can already browse the data in full resolution right here in the discovery phase. So let me remind you that all this is on the fly, of course, from the GeoZarr store. Let me highlight the metadata. Unlike the traditional Sentinel-2 cloud organization, 1 cog per band, here we leverage the Zarr structure for EOPF with measurements and other auxiliary assets. And for Sentinel-2, we have a central asset called surface reflectance, and contains all the band organized as variable, fully described via the band construct and the data cube extension. And this enables really the true multidimensional representation, which is the key strength of Zarr. And among the linked resource, we have 3 important ones. The Zarr store link. This is the one Xarray or any other cloud client will open to use the data. A preview image of the granule, the one you see on the STAC catalog, and a link to TiTiler Previewer. And these simple tools already let you screen the data and play with bands. You can combine bands to produce an image. So here, for instance, a near infrared image. You can rescale, apply a color formula, and again, you can browse the data. Of course, this is more I would call it an image debugger tool, so just to see one granule at a time. But even here, you can already browse the data quite high resolution, and you can also combine it with band math, for instance, to make an NDVI. This is how you can do it. Here, you can again still rescale. We won't use a color formula here, but more a color map that applies to the scaling. So before I close this demo, a few things to remember. Everything you see here, the software, the service, the data is open source and free. So all components are reusable and all image tile previews are generated live from the cloud native data. This is the whole point of EOPF Explorer. So now, we will bridge from discovery to screening, and you have found your scene. Now, let me see how you can browse it with the Sentinel browser. And this is the Sentinel browser developed by our partners at EOX using EODash, their open source web UI framework for composing complex dashboards. So on the left, you have this item list, which dynamically updates how you pan and zoom the map. It actually used the STAC API for that. You can filter by collection, cloud coverage, and as you hover on an item, you immediately see its datetime and cloud cover. You click, and the scene renders on the map. All of this served, again, on the fly by TiTiler directly from the GeoZarr data. On the bottom right, you have the full STAC metadata for the selected item, collection, datetime, identifier, other metadata assets, everything you expect from a STAC item. You notice the map button here, a zoom, and Importantly, an export function. You can export the current map view and keep that in mind because we will use exactly this capability later in the storytelling demo. So here we switch to a 3D globe projection. So you can have this different projection to view the data. You can drag to tilt the camera and get a perspective view of the data over the Earth. This is a small thing, but it makes the data feel tangible. And as you can always go back to the standard 2D map with a single click on the same icon. So now this is where Sentinel browser really shines. So let me take a moment here. You're looking at the layer control panel. You can reorder the layers on the map, but more importantly, you can build custom band configuration, again, by dragging and dropping bands into the expression. The bands are color-coded to help you recognize them visually. And here, for instance, a false color composite. Again, this is not pre-computed. Everything is live. You can go further. Here, for instance, we generate an instant NDWI, a water index, by just selecting the right bands. You can, of course, select a different color map selection. And we have the same principle with a spectral ratio, here visualizing the direct mathematical relationship between band 8 and 4. The rescaling slider lets you fine-tune the stretch to bring out the contrast. And you see that every time there is a real-time request to TiTiler to read the band from the Zarr store, compute the expression, and streams the tile back. Now we have this comparing mode where you can select another collection or the same collection, and you can pan and zoom the same way, and you can select on the left and on the right different data to compare them. So you can compare, of course, natural color, but you can also, you can also go and select another stuff. Sorry, I clicked wrongly on the, I don't know if I can just select again. Oops. I wanted to show you also the, sorry, I clicked somewhere. I should have clicked. So, yeah. Sorry, I'm gonna move to the example applications, and I could show you the mosaic later if I have time. So now we have seen those two applications, so the STAC browser and the Sentinel browser. Now I'm gonna show you how to use all these components and how to make them come together into something that you can deliver to an audience. So I will start again with the Hello World in Earth observation with an NDVI. So we chose NDVI for this story because, yeah, everyone knows it. Everyone has computed it at some point. And it is precisely why it is useful here. You already understand the science, so you can focus entirely on what the platform is doing. So what you see here is an interactive story, scroll-based, with live maps and transition. And this entire page is just a markdown file. The maps are powered by EOX Map, a web component from the EOX element library developed by EOX. And the storytelling behavior comes from the map animation. So you probably remember the export function in the Sentinel browser. This is where you can use what you have built on the Sentinel browser directly into and copy paste directly into your map, into your markdown. And here what you see is server-side rendered, again with TiTiler. It evaluates the expression, applies the color map, and returns the PNG tiles. But you can also use what we call data in the browser, and now the same in the VI, fundamentally different under the hood. This is client-side. So the raw data ZAR is directly streamed from S3 into the browser, and OpenLayers computes the index on your GPU via WebGL. And as I scroll through the preset, the full spectrum vegetation, then crop health, each switch is instant because the data is already in the browser. So no round trip to the server compared to TiTiler. So you see that the same Hello World examples, but it reveals two different complementary architecture, server-side and client-side, composed from open source building blocks, TiTiler, OpenLayer, EOX element. You can pick whatever fits your use case, you can assemble it. And remember the map export we did in the Sentinel browser that helps you to build this thing. So for each of the approach, I'm gonna focus on the GeoZarr one with OpenLayers. You have in the landing page of EOPF Explorer a software integration page. And it starts with the basic. So it gives you a step-by-step walkthrough that takes you from zero to a working map application. And you can start with a basic map setup here. So you basically combine RGB bands and you see the data flowing in directly from the data from the S3 in the browser. To be fair here right now, there is a lot of moving pieces in the OpenLayers GeoZarr software to improve the data flow. And this is impressive, the number of contribution we already had from the community to have this software working seamlessly in the browser with the EOPF GeoZarr data. So you see that you have snippets of code that you can easily copy paste into your own data, into your own app. We describe the key features, the configuration details. We have here the same for NDVI, and again, showing that you can play directly with the data without having this round trip you would have with TiTiler. And again, you can copy paste easily the data. And here we even have an example how to integrate that with STAC. So directly from JavaScript, you can create the STAC API and retrieve the data to create, for instance, a mosaic over the data. So here you can easily build an application from scratch using JavaScript without having to deal with a backend. Again, the search logic, the scene loading, the map setup, everything is described into this software data. Okay, now I don't know if we have time for another application. I guess yes. And I'm going to show you this LavlaFlow story and to show you how you can make another story with other data. So let me show you. Okay, here. So the NDVI story showed the approach of server side and client side. Now we will go deeper into what TiTiler can do on the server side. So this is a story of the 2021 Cumbre Vieja eruption on La Palma. And so we started with a true color view, 6 days after the eruption. We can see the plume, and we can highlight the lava flow using the SWIR data. And then you can see that we can easily go through time with the data. In the markdown here, we are pointing to different timestamp over the STAC catalog. And these data are selected and rendered by TiTiler automatically. So you can build easily an entire story over time. And you can, of course, switch from a view to another. Here we are still on basic band combination and let's say, expression to do that, that visualization. And again, at the end of it, we always describe how we build this. And again, all the software, the code, the data you see here are open and free, and you can play with it and reproduce it easily on your own. So let me just put that as a segue for the next webinar. We have seen discovery and visualization and screening, what we call screening. Next time, in the next webinar, we will focus on data analysis because we believe it deserves its own webinar, and we will focus on advanced on-the-fly analysis. We will use for that OpenEO workflows. We will also use OpenEO Studio as an accessible interface for synchronous OpenEO processing, and we will also see how we integrate that in another storytelling, and how to use that also maybe in other application, even more advanced one. So feel free to register soon as this one is done. Back to you, Sabrina.
Thanks, Emmanuel. So now we'd like to really encourage everyone to try it for yourself. You can see here that we have the EOPF 101 book available on the toolkit where you can learn the basics, explore some real-life case studies from different examples, everything from wildfire monitoring and even generating overviews for Zarr data. And then we actually have a community notebook competition running right now. You have one more week to take part. It ends on Sunday at midnight. And this gives you also a chance to write your own notebooks, convert some of your existing workflows to using the Zarr data from the sample service, and just try it out yourself. So please join us for this competition. And then we also welcome you to head on to our website, look at the data model, explore the software, explore the services, and we really need your feedback on how this development is going with Zarr. So please make an account on the discourse forum, share your opinions, share your struggles, share your challenges, and share what you're building, because this is a great way right now to share your feedback so that we can incorporate it as this transition continues. So now it's time for Q&A, and I welcome everybody to click on that button at the bottom with in the black ribbon. There is a question mark and Q&A. Click on that one, you'll open a little box and you'll be able to share your questions. There are some people who are already putting a few questions in there. You can also upvote questions that you like so that those will appear at the top. And while I give people a chance to share their questions and upvotes, I'd like to ask Emmanuel to maybe talk a little bit more about the multi-scale pyramids that we have in GeoZarr. How does that work, Emmanuel? Over to you.
Yeah, indeed. So what I presented all along here is, of course, a data on top of the data that EOPF Zarr sample service is producing. So those data are what we call internally supercharged data. So those data basically are the data in still, and we keep the EOPF structure, of course. But what we are going to do is that we are going to rechunk the data to be more improved for visualization and streaming. We're going to shard them thanks to Zarr v3 to actually optimize the object storage. So basically a shard is putting together all those small chunks into a single file. And we create out of the 10 meters, 20 meters, 60 meter resolution of Sentinel-2, we start building a pyramid. And then on top of that, we create even more overviews at 120, 360, and 720 meters. And this offers the same multi-resolution feature you have with the COG, with the Cloud Optimized GeoTIFF, in order to zoom seamlessly from continent to field and to play more easily with the data. What is important here is that this is not our bespoke design we have done for EOPF, but this has been built with the community. We had many discussions with the Zarr community to build on top of Zarr what is called now Zarr conventions to define projection information, spatial information, and those multi-resolution, what we call multi-scales information inside the Zarr store. So that's about the for Sentinel-2, but that's would be the same for other missions.
Thanks, Emmanuel. So as we start our Q&A, we have quite a few questions coming in. I'd like to also welcome Stefan Meisel from EOX and Razvan Alexandru Kosak from ESA to the panelists. And I'll start with the first question here. So one of our attendees is asking, the tools you showed are mostly for visual applications, right? What if we want to download a small part of a specific Sentinel-2 scene? Must I use Sentinel repositories for that? What about Python API access?
Okay, so to answer the first part of your question, again, just here, first of all, this project is about visualization, right? But the line is thin between visualization and streaming actually the data for more advanced processing, as we will see in the next webinar. But basically, if you want to download a piece of data for processing, you can still do it. It's still feasible. You will still have a stream of data that will locally create a file on your computer. But again, by design, Zarr is done for actually processing on the fly your data, to stream your data into a processing workflow, to a processing chain, to a processing framework that actually give a result without having to download and leave actually the tooling doing all the requests and cropping for you. Typically, Xarray is the perfect tool for that and one of the reference tool. And to answer your question about the Python ecosystem, this is, of course, Xarray as a reference. And for Xarray, there is a library called RioXarray, for which there is already a support of EOPF, of GeoZarr in general, that opens EOPF GeoZarr, and for which we are also now integrating the write support. So if you use Xarray, I advise you to use RioXarray to open the EOPF data. And again, if you go onto the landing page, so maybe let me share my screen again to show you. So if you go on the EOPF Explorer, you have this page, Software and Services, in which you can find the different software, the different, let's say, project or initiative in the portfolio. So how to use TiTiler, how to use the NDVI, OpenEO, OpenLayers. We are preparing one for RioXarray and Xarray because, again, we are waiting for RioXarray to release properly. But when it will be released, there will be a new story here for you to discover, a new software page which step by step can explain you how it works. We want actually this website and this landing page to be live and to come with new feature along the way. I see a lot of
Yeah, thank you, Emmanuel. So the next top question here is, I have explored the EOPF stack collections before, but I saw that you have limited data. Why? So I think this is asking the question, what's the difference between the EOPF sample service stack catalog versus the one with EOPF Explorer?
Yeah. So on that question, we have focused most of our work on Sentinel-2 up to now, because this is the, let's say, collection for visualization and that has the highest resolution in terms of optical data. We have also worked on Sentinel-1. There are a few Sentinel-1 samples as well. This is planned to be produced more heavily in the next weeks. But with Sentinel-1, we have a more limited, let's say, visualization capability, because the Sentinel-1 up to now, the GRD especially, are still georeference into the acquisition projection, and we would need probably to use Sentinel-1 NRB, so the ARCO, so the analysis ready level 1, that is already reprojected, for instance, in UTM, in the same reprojection as Sentinel-2, to be really, let's say, relevant and efficient for visualization. So that's why we haven't focused on that. Our focus now is really also on Sentinel-3 to have the same functionality as per Sentinel-2. And with regard to the data volume we have already a very consequent data volume for Sentinel-2. We are actually reprocessing entire archive that is available on the Zarr sample service. So it's basically Sentinel-2 over Europe. So from November onwards, all the data are available on Europe in GeoZarr. We need to see with ESA how this will be designed in the future. But yeah, we hope to have a large amount of sample data, and it's already the case. There are almost 80 terabytes of Sentinel-2 data available in GeoZarr.
Thanks, Emmanuel. So I think there's a popular but question here that maybe it would be good for Razvan to answer. So the question here is, what's your consideration for choosing Zarr instead of other formats, e.g. COG file or ICE chunk? It's the classic why Zarr question.
Why the Zarr? Yes, indeed. Thanks for the question. I mean, yeah, in terms of COG today, we only do the transformation for the Sentinel-2 data. And for us, not for Sentinel, sorry, for Sentinel-1. I mean, and why Zarr? Because we want to have a harmonized, let's say, format across all the Sentinel missions, Sentinel-1, 2, and 3 land products. The Zarr also allows for efficient access to the data. It allows for more interoperability as well, and for the progressive visualization that you have seen Emmanuel showing at the different layers directly from the data. So those are the main reasons. If you want to look into it, there's more information on the website as to why, and you can also join the discussions that we've been having.
Thank you, Razvan. All right, so the next question is about TiTiler. And the question is, can you select the time step in the TiTiler Explorer?
I don't know what TiTiler Explorer is meant here. So TiTiler right now function as two parts. So there is the base API, which lets you choose the collection and the item ID. So you can render specifically one item and select the variables and the expression you want to see. And then we have what we call a mosaicing API. And this mosaicing API allows you to parameterize the same parameters, but also to go through through time to see the let's say the mosaic, and then combine the data together. We haven't planned to show that today because we believe this is more for data analysis. Here we wanted to really settle the ground around the granules and how the data is organized in the STAC catalog. But in the next webinar, we will go over really more over how those mosaicing and all those processing on the fly on top of data cubes can be done easily. But yes, in TiTiler, with TiTiler you can do that. With the Sentinel Explorer I demonstrated for screening, you can actually already select the date time, and this using this actually it virtualize a bit this timeline by using the STAC API to select for you the data and then render it directly in the browser.
Thanks, Emmanuel. It sounds like maybe they were referring to the Sentinel Explorer. So there's another TiTiler question here, which I think you also touched on before. And the question is, I'm assuming TiTiler is returning the tiles from the GeoZarr store. The question is if that TiTiler is customized for EOPF or is it the vanilla one? And I think based on what you said about how you have been also contributing back to the libraries itself, it's actually the vanilla one is now customized and can run and be used with the EOPF Zarr data. Is that correct?
Yeah, to be fully transparent, there is still a repo. So TiTiler by design is made to be designed to be application designed in the sense that you can always deploy TiTiler on its own, but you should, when you design something more production grade, you should have your own TiTiler deciding on which parameters and the endpoints, etc. So for EOPF Explorer, we have designed our own TiTiler EOPF. Why? Because we also needed to design and to implement along the way the GeoZarr reader, because TiTiler is based on readers. So there is the Cork reader, there is the STAC reader, etc. When we have started to implement the GeoZarr reader, and of course, we have implemented the GeoZarr reader alongside with the conventions we were establishing with the community. And we could not integrate that directly into the mainstream TiTiler, a GeoZarr experimental one. So we have this TiTiler. We plan probably by the end of the year to have a proper GeoZarr specification at OGC level. And after that, and even probably before, there will be a proper GeoZarr reader in TiTiler. But already today, it's open source. You can use the reader and import the TiTiler EOPF1, which will become the official GeoZarr reader. And you can do it easily because we also publish the TiTiler EOPF as a library on PyPy.
Thanks, Emmanuel. So this next question here is about the APIs. So how performant are the APIs? Can we use this for commercial users? What if we have agents that access this via MCP? So this is the question.
So we are still at that stage, and Razvan can confirm that we are still at the stage where with ESA, we are encouraging the user to get familiar with the new EOPF Zarr format. The initiative you have seen in this EOPF are for outreach, and we don't have a full Copernicus, let's say, data set and data collections. So here you have mostly samples and, let's say, demonstration purpose services. But they are already designed to actually support a lot of users. And we are actually very keen to understand how far we can go. So I want to tell you, just go, test, reach the system, get back at us. We have also instrumented a lot, everything. We want to see where it behaves well, where it will fail. Probably we will have failures at some point. We will need to understand how the design. But theoretically, GeoZarr is made for streaming the data as much as possible. So please play with it and please just get back at us on the discourse with your feedback.
Thanks, Emmanuel. So another question here is about GDAL. How will the GDAL 3.13 enhanced support for Zarr enable usage of Zarr data in future workflows? What is the difference between using Xarray? And then a follow-up question is, where does GeoZarr stand in the future of Zarr? Should we see it as the upcoming standard for geospatial Zarr assets?
Okay, so regarding GDAL 3.13, so GDAL 3.13, I don't know if it's already out, but it should include a first support for what we call GeoZarr, so the first Zarr conventions, and opens already the EOPF GeoZarr. A few days ago, I posted the link here because it was super interesting. We had a contributor, Vitse, that made a webinar on Pangeo about GDAL because he contributed it a lot to, so let me find where I can put the link here. He contributed it a lot to improving the data access pattern to GeoZarr. And he demonstrated how to use it in QGIS. So of course, this was all tailored because he actually recompiled GDAL to work with QGIS. But from what I understand, from GDAL 3.13 onwards, there is the support for the Zarr convention and the GeoZarr, and it will improve along the way, and you will be able to use it with QGIS and all other tool ecosystem that actually use GDAL as a backbone.
Thanks, Emmanuel. Okay, the next top question is about analysis. So when one would use the data from EOPF in analysis in Python, would it not be greatly bottlenecked by the network bandwidth? And are there no server-side restrictions for large data requests?
That's a good question. Right now, we don't know what we have already done some testing where we read basically Sentinel-2 level 2A at 10 meters using 8 bands, flowing into an OpenEO workflow and creating an NDCI on the fly. That's what we will see in the second webinar. And basically it works. All the data streams properly. And of course, it depends a lot on the infrastructure. Of course, it depends on the object storage behind the scene serving the data. But here already with this project, with a much smaller budget than a CDSE, we can already do great stuff. So I'm pretty convinced and confident it might work. Yes, Jonas, you want to complete?
Yeah, I was also wondering whether this question is aiming at the future where all data is distributed like this, right? I think that's an interesting idea that when we get to that problem that all data is available this way and cloud scale distribution has to think about bandwidth. I think we'll solve that problem when we get there. And in the past, I'm thinking of other platforms that distinguish between in-region access, so same cloud provider, same region, right? And egress, so where you actually download the data to other clouds or other servers. I'm sure there'll be a mechanism like that. But for our project, there's currently no limits. And like Emmanuel says, I can only stress we want you to test them. So yeah, please try your workflows. No DDoS attacks, please. But if you have realistic workflows to try out, please go ahead.
Thanks, Jonas. I see a number of people raising their hands, so I'd like to encourage you to type your questions in the Q&A box and also upvote other questions so that we can prioritize which questions to answer. So here we have several more questions regarding data access. Will there be near real-time Sentinel-2 data available in your STAC catalog is one of the questions. I'm guessing no. Emmanuel, you're muted.
Yeah, sorry, can you repeat? Oh,
The
yeah,
question
please
is,
go.
will
I
there
will
be...
answer.
Okay, Raswan.
The short answer is no, let's say, because the data that you see on this demonstration service comes from the EOPF sample service. So there's data currently from some years ago. We will probably have some more recent data, but no near real-time data. No.
Thank you, Raswan. Then the next question is it possible to access EOPF Zarr directly by X-array or Rio array already? And I think, Jonas, you would like to answer this question, right?
Okay, sure. Yeah, I think the best, yes, it is. And I think the EOPF toolkit probably has nice resources for showing how that's done.
Absolutely. So yes. And then the next question here is, how much can you save in data volume from the actual save format to the EOPF Zarr?
That's a very good question. We plan to benchmark this in the later stage of this project. But let's say as an empirical and first assessment, let's say that there is, in terms of data volume, not so big improvement in the data volume itself. But I believe that at some point, the good chunking and the good compression parameters, and maybe also the stacking of the data over time could help into having better data storage volume performance. And also the way the data are encoded, Zarr is based on codecs that encode the data into the implement the storage layer. So all those improvements can be also done there.
Thank you, Emmanuel. So the next question is about TiTiler endpoint. What about the TiTiler endpoint provided by EOPF? Is it freely accessible? Will it have some kind of quota? I see Stefan shaking his head.
Yeah, no, right now, no quota. It's again open and free. You can access it. I will copy paste immediately the API for TiTiler EOPF, so you can play with it. Again, we are expecting your feedback here. We want to see how this behaves and how this can actually support a load, and we will benchmark all of this and monitor. And there is no restriction so far. Of course, at some point there may be some monitoring as you can have on CDSC, but for this project right now, it's all open and free.
Awesome. Thanks for clarifying. Another question here. To add, I wonder how precise and how detailed my data request could be, i.e., could I specifically get values from Zarr imagery for thousands of points instead of a polygon extent?
Yeah, I was about to type an answer to this one.
Awesome.
Yeah, I think this question was about like extracting data for specific areas or now even many points or so. Like I mentioned, we already have some services that support this in our project, and not for like many points. That's a different case. We maybe don't support that well currently, but this is really a good question for, again, the EOPF 101 or also the discourse forum. Then we can go a bit into technical detail.
Absolutely. As we are slowly running out of time on the webinar, we will try to get as many questions as we can in, but don't forget to post any additional questions on the discourse forum so that we can keep the conversation going and also answer any questions that pop up later on when you are trying out EOPF Explorer for yourself. So let me pick another question here. So there's a question about deep learning applications. I don't know if this is very applicable here, but there's a question about converting. Is it seamless to convert Zarr formats to become deep learning tensors and vice versa for deep learning processing? Anybody know anything about that?
Yeah, maybe, I mean, there's not a lot very specific about Zarr for deep learning compared to traditional images. One advantage maybe is that if you have this chunked organization, you can read the data a lot faster, which is super important for keeping the GPUs busy, because an idle GPU wastes a ton of money for you. So I think in that sense, Zarr is better for deep learning. But in terms of workflow, there's not necessarily a lot of difference. And yes, it should work also for PyTorch and so on.
Awesome. Thank you. Because there was also another question about PyTorch. So I will mark that as answered. So there's somebody who is asking about handling differences in data interpretation between GIS clients for visualization, especially the ArcGIS ecosystem. Any answers regarding that?
I didn't get the question properly. Can you repeat that, Sabrina?
The question is, how do they handle differences in data interpretation between GIS clients for visualization, especially ArcGIS ecosystem?
Okay. So Zarr is a specification. So I suppose the question is about how it will be seamless through the tools to use the data, right? That's
Yeah.
how I interpret the question. So again, Zarr is a convention as it was for GeoTIFF. It's a file format. It's an encoding. It's very large and very modular. So it has a bunch of codecs, etc. What is on top of Zarr core, let's say, is what we have built here, which are the Zarr convention. Basically, what are the attributes that says, oh, this is a UTM projection. This is the coordinates are encoded in UTM or in lat long, or etc. And here how the data is organized by resolution level. And this, of course, must be adopted by the client you use. In this project, we try to onboard and engage with the maximum of maintainers and libraries in the open source community. So for ArcGIS itself, I don't know when they will pick up on the Zarr conventions. Probably when the data, when the conventions will be included in the GeoZarr OGC specification, I suppose, which is targeted for the end of the year.
Thanks, Emmanuel. So with that, I'd like to thank again all our panelists here for answering the questions. We managed to get 23 questions answered, and there's still 7 questions open, but I encourage you all to continue the discussion on the discourse forum. And I thank also all the contributors who are making the various open source libraries that we're using possible. And thanks also to all of you in the audience for your questions and for your attention. So I wish you all a good rest of the day, and thanks for joining us today.
Thank you.